Okay, so so for the recording, I just want to mention that um, we only have two more classes, I think, before the review, and then the other thing is that the final is going to be on the 26th, which is like the day after Memorial Day, which is a little bit nuts, but I guess that's how it worked out. Okay, and okay, so what I want to do today is we have, let's say, a project uh, which is going to write a timer. And what this timer is going to do is it's going to take a light and it's going to turn it on and off. Okay? So so far I don't have any code here. Just have an empty class called timer, right? So now we'd like to do is we'd write some code to turn it on and off. So first I'm going to do it the wrong way, the non-testable way, and then we'll go over the correct way to write it. Okay, so um, let's imagine we have a light, and our light has two methods. Let's say, for example, as a Boolean, uh, let's say uh, on, and initially it's going to be false, and then it'll be private, and um, then we have a method called on, and then what on is going to do is a public void or a turn on maybe, and then turn on is going to just be a little method, and it's not going to do too much. It's going to just say um, turning on. Well, what would I do? I did something bad. Uh, Turning, I think I did control, turning on light, and then we'll have a method called, and then it will be, um, we'll just set on equals to true. And why we need this, we'll see later on. Uh, but right now, we're not really going to use that. And then we're going to have turn off, which is going to set on to false. Okay, so this is a real light, okay? Okay, and then we have timer over here, which is going to be something called, let's have a method called control, a public method, a void, public before that, um, public void, control light, okay? And okay, so what this is going to do is it's going to do, let's say, light equals to new light. And it's going to, based on the time of day, it'll look at the current time. And I keep on forgetting what the method is. So I'll just look it up real quick. Does anybody know offhand the Java method for getting the current time? Java method, actually, uh, getting uh, current time or get current time, um, current time. So look it up over here. And it's called local time now. Okay. So local time. I don't know why they use that method or that class name. So we'll get the time. We probably have to import something. And then based on let's say, we always going to, if now dot, let's say, get our I assume this is between 0 and 23. So if it's, let's say, so 0 to 23, so let's say 8 p.m. to, let's say it's the sun, let's say we'll turn on uh, between um, let's say 8 p.m. and um, let's say 6 a.m. I don't know. Let's say it's something like that. Okay. So if the hour is let's see, if it's greater than um, 8 would be 19, right? All right. 8 p.m. would be 19. The hour is greater than 19, and the hour is before 6 before 6 a.m., right? So that would be like 5. So it's between those two times, or the greater than or equal, or less than or no, it goes like this. I did it the wrong way. It's less than or equal like that. Okay. If it's between those, uh, what did I do wrong? How you do less than or equals? Uh, I think it's okay. Then, if it's between those times, then we're going to light um, that turn on, else um, light that turn off. Okay, so this is our method, and let's say it works. Okay, let's pretend this works. Okay, so if we run it right now, if we go to main and we call um, timer, um, that's what's called timer equals to new timer, and then we could do timer dot control light, oops, and if we run it, it should turn on the light, right? Because that's after 8 p.m., right? If we wrote the code correctly. Um, see if it works. Okay, so it worked. So we turned on the light, right? So it's the evening and it turned on the light. Okay, so the question is, what's wrong with this code? Okay, this is perfectly working code, except it has a bunch of testing issues. Okay, so what are the issues? Could anybody think of any problems with this code? I could think of, let's say, one obvious one, uh, and then one really obvious one, and then there's another, wait a minute, one obvious one. Let's do one at a time. Well, the one is really obvious, right? The first problem is how are you going to write a unit test, right? Because the, um, I'm sorry, here's the code. I'm sorry, this is the code that's bad. I'm sorry, I was in the wrong place. I apologize. Right. So if you look at this code over here, there's a bunch of problems, right? The first obvious problem is that we're returning void. So how are we going to test to see? And this light over here is private, right? So how are we going to test to see if it actually went on or off, right? How are we going to write there's no way to tell, right? Right, so does everybody understand that? Right? How would we write a unit test to see if it actually went on or off? Right? Because it's going to print something, right? But if we run this in the middle of the night at 2 a.m., automatically we want it to be able to test it then. We don't want to wait, we don't want to he needs someone standing in front of it every time it runs to validate it. Okay, so it's easy to do. So all we have to do is we could actually do Boolean, and we could actually go back to the light, and we could actually remember we had this on or off, so we could actually um, generate a getter. Um, uh, okay, somebody here. Wait a second. Uh, Somebody waiting. Sorry. Okay. So I know someone's waiting is um, when the meeting controls pops up. Okay, so I'm gonna generate a method called isOn, right? And it's going to return it. So over here, I could return is on, right? Whether it's on or off, right? So for example, if I go and I create a unit test, right? So I could generate a test, right? Which would be really easy. And I just go here. Oh, I forgot. Let me do it again. Um, I forgot to click. Generate. The problem with these things is if ever I have to actually remember how to do it, I'm not going to remember because I'm not going to remember how to do that. So um, that's the problem with all these automatic things like AI. You forget how to do things yourself. Okay. So anyhow, so we could do over here, we could do timer. I could just copy the code from main, and I could, okay, so all I have to do is assert um, that assert, um, I think true, would have to assert true, and that timer, so that this returns true, right? Right, that's my unit test, right? So it should return it because we're running it at night, right? So if we run this now, it should return true. It should pass the test, right? So now we have a automatic test, right? Okay. So which brings us to our next problem with this code. Okay, what's the next? Anybody could guess what the next problem is? Oh, so failed. Uh-oh, what it failed? True. Timer control light. Uh, why did it fail? That's interesting. Uh, assert true. Uh, control light should have returned. Is on. Uh, it should have turned it on. Wait a second. And that sets on to true, and is on returns on. Uh, where is on? Declared? Here. Oh, put it in the wrong place. No, but it still should have worked. Let me just see why it didn't work. That's interesting. Uh, it should have returned light is on, right? Because let's just run it one more time. So it actually, let's run it from main again. Just to make sure that it works. It should have said it's on, right? Oh, it ran, said turning on light. Why did it fail? That's weird. Uh, wow. If, if it said turning on, uh, if it turned it on, it should have returned whether it's on or off. It's on. Uh, wait a second. Let me just check. Print. It's okay. Let me just print this value. Okay, just make sure. Okay. 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 So I just want to see why I failed. That's crazy. Okay, so I go here, but then I want to run main. Run. I want to run main. Why is it running main? Run. Uh, oh, here we are. Okay, so it should, I just want to see what it does. It's returning false. If it turned it on, oh, maybe my code is wrong. Hold on a second. Maybe I turn on equals true, turn off, on equals false. What, I'm sorry? What?
The if statement may.
No, but it turned it on. See, it didn't turn it off. Oh, this is turning off light. Oh, okay. That was my problem. It was actually turning it off. Uh, so, okay, you're right. My if statement is wrong. So if it's greater, so if the hour is, let's say now it's going to be, uh, it's greater or equal to, um, if it's between, maybe it's eight, let's make it 18. I don't know. Maybe I'm off by, okay, so 18 should be 6 o'clock, right? Okay, let's try one more time. So if we run main, it should say it's turning.
Because this and less than 5.
Oh,
Okay.
or it should be or, it can't be,
Yeah.
oh, it can't be above, okay, I always make that mistake, right? It should be an or, right? It should be, in other words, it can't be greater than 18 and then less than 5, right? It's or, right? Right, okay. So, no, if it's greater than 18, but let's say, oh, because then it's going to be, or it's less than 5. Well, let's say it's 6, then it's going to be, it won't be either of those. Okay. Okay. So, okay, now we fix that. Let's try it again. So we run main. Okay, I always make that mistake uh, with times. Okay, so now it's turning it on. Now if we do our timer test, so it was good. We wrote a unit test, huh? We actually found the bug in our code, right? Thank you for helping me. Uh, Sometimes the unit tests actually, you catch a bug. Uh, okay, if we run it now, it should work, right? So we run our timer test and yay, it worked. Yay. Okay. So it turned it on, but more importantly, we were able to test it without looking at the result, at this output, right? So that's great. Okay. So what's the other problem with this code? Well, the other problem is, what do you think? Well, could you run this in the morning? What's going to happen?
Okay.
It won't work, right? It's going to fail. Okay, so that's the next problem. Okay, so let's just write down all the problems with our code, with this code. So one problem we fixed. Um, okay, so there were actually three problems. Okay, so let's go through the problems. Number one is, so three problems. Okay. One is we have to return a value, which we did for unit testing. Okay. The next problem is that the results are not it doesn't have a predictable it's not always going to return it's not a constant result, right? So the result uh, changes based on when it is run. I guess you could do something like in the test itself, you should, like say, if it's daytime, then it should do false. Maybe you could fix that up. Okay, but basically, let's pretend that that's an issue, right? In other words, it's not going to give the same result whenever you run it. Okay, so it's dependent. In other words, it's dependent on something else, meaning the time of day, right? I.e., this method relies on when the time of day when it runs. Okay. Okay. Then what's the third problem? The third problem isn't so obvious. Third problem is that over here we're talking about a real light, right? Like a driver. Imagine like a driver for like a real light bulb, right? Now, chances are that we want to be able to run this unit test wherever we are, right? So even on the server that doesn't have a light bulb attached to it, right? So my laptop might have the driver for the light bulb over here, but in real life, right, when we run on the server, there might be, we want to be able to test our code and we don't have any light bulb, right? Okay, so that's the third problem. Third problem is that we're relying on, it's similar to two, which is that we're relying on something external, right? Two is that it's random. Three is that it's relying because we're going to solve it different ways. So we're relying on specific um, hardware being connected to our computer, right? So, okay, any idea how we could solve two or three? Any of these problems? What would be a way to solve number two? That how can we make it not random? Well, simple, passing the time, right? In other words, for example, let's say over here, we pass in a local time. Oops. So rather than letting the method use whatever time it's running, what we're going to do is we'll pass it in. Okay, so we have a method called, maybe I'll call it a current time, maybe be a little bit more, so it won't be confusing, and we'll pass it in. And then over here in main, we could pass in the actual time, right? So actually, we could go like this. We could just do this. local time now. Doesn't know what it is. That's weird. It knew about it in another file. Okay. And then, so over here, this would be real life. In real life, we would pass in the real time. But in our unit test, right, where it's expected to turn on, well, we'll pass in, let's say, um, okay, I need to find um, to get um, a treat to return a specific local daytime, local uh, daytime. So we would use um, isn't there a better way to do it? Uh, okay, I'll just copy it. So, so for example, uh, okay, there's no local time. Uh, okay, whatever. Let's just. I wonder if this is going to work. Could we local? Oh, I did local. I have local daytime or I have local time, which is okay. Look, I want specific local time. I don't want. I did daytime. I want local time. Sorry about that. Some. Oh, here it is. Local time of. And let me just see something I could copy. Okay, so we could do like this. We could do local time, let's say at midnight, which would be 00, right? So in the test, we could pass the local time, again, it's asking me, uh, of, and let's do midnight, right? So we know it's always going to be dark at midnight, right? So this should also work now, right? So we solved problem number two. Isn't that cool? Okay. So did it run? Uh, oh, I forgot to rename this. Um, current time. So let's call this, and that, and let's run it again, our test. Um, actually, let's run it from here, and oh, it ran the test. It's running the test, I think. Okay, and so actually that ran, and then, so if we run it from the test, now it's always going to return it on because we're passing in midnight. So, but if we run it from main, we're passing in the current time, right? So for here, for example, in the test, I could write actually more tests to see, let's say during the day, it should it should turn it off, right? So I could do. So I could do, um, for example, over here, I could do assert false when it's in the middle of the day, like, right? So let's say 12, or is it 11, right? 11 would be the middle of the day. So we run this now, it should also return false, right? So now we could actually test out our logic rather than, um, rather than relying on, what time of the day is it when I read it? And look out the window, right? Okay, good. So it actually, so our test passed. Great. Okay, so the third problem is what's called, I don't know if you've heard of it, but it's called like a mock. I forgot. There's actually, I haven't worked that much with it, but the idea is we're going to pretend we have, it's what was the third problem again? The third problem was that this light me method was really like it's actually working with a real light. But let's say we want to run this on the server, which doesn't have any light bulbs attached to it, right? How's that going to work, right? That was our third problem. So the answer to that is that we're going to mock, have a mock light, okay? So the idea is like this. We'll have something called it's very simple. It's basically, we're doing the same idea, um, but we're going to pass in a light, okay? So the method is not going to know really which method is being called. So we'll have, let's say, a abstract class called called device, and device um, abstract. The reason I gave it abstract because I'm going to put the on and off into it. So, um, and so the abstract thing is going to hit, uh, yeah, I want to have actually, I'll make it interface. Forget about that. Okay. And in my interface, I'm going to have these three methods. Um, okay. And I'm going, I'm going to put these three methods in here. So, and you don't need public and interface, right? Because, and then, um, so now we could have a general type of device that's being passed into the timer, right? So it doesn't know exactly which one it is. And then we'll have light, will implement this um, device, right? And then we're going to have a new object called, let's say, pretend light or mock light. And mock light is also going to implement the device, right? And in order to implement it, basically, I'm just going to copy the light thing, except I'm not going to actually um, turn it on. I'll just say pretend turn on. So go to my mock light, and over here, I'm going to, um, I'm just going to, because it's only being used by the mock light's going to be used by the unit test. So I'm just not gonna even print anything. There's no point in doing it. And I'll just implement. So all it's going to do is when we turn on, it's going to set on to true. When we turn off, it's going to set off to false, on to false. And then when you call this, it's going to, um, so basically it doesn't actually do anything, right? Except it keeps track of this state, right? But that's all we need, right? For our unit test, we could get by. So basically, what we want to do is go back to our timer method, and let's pass in a device, um, and then instead of what it just happened. Oh, I just okay, and then um, we're gonna get instead of um, having light be passed in, it's going to be device. Actually, it's a little bit more generic now. It's even better, right? Device, and then device. Actually, I don't need this anymore because we tested it. And just should be device is on. And then in real life, I'm going to pass in a real light bulb, right? When I actually use it, I'm going to pass in the real light bulb, right? But in the timer, in the test, where we might not have a real light bulb, right? So here I'm going to pass in the pretend light bulb. It doesn't do anything, right? Um, uh, um, new mock light. Okay, and we'll do the same thing here. So, so now this will run on the server, and we run this, it'll give us the same results that we want because we're only concerned really, knows what is it we're really testing? We're not testing to see if the light bulb works, right? We're testing to see whether our logic, our timer logic works, right? Whether we're turning it on or off at the right time. So that we're testing correctly. With that, the unit test correctly is testing, right? Whether put it on or off. And in the main, we actually are going to turn on and off. When we really want to do it, we're actually going to um, run the real one. It's actually going to turn on the light, right? So in real life, this will happen, but in our unit test, where we don't have a real light bulb to test, we'll pass in the mock one, right? And the mock one will be in our place, right? So that. I think there's something called there's like a whole library for mocking. I'm not really into that much, but what it does is it reduces the dependency, right? So what we did was we removed we had three problems and we had three different solutions, right? One problem was no return value, right? So we that was easy enough. We just gave it a return value. Second problem was we're relying on the random time, so we passed in the time. The third problem was we were relying on a specific device, so we just passed in the device. So this test didn't care. This method doesn't care what specific device is passed in. Whether it's a real light or a pretend light, the logic is going to work the exact same way. Okay, so that's pretty cool. Okay, okay. So any questions? So I think that this is really cool. Problem, to work on. Okay. So next, what I want to do is, we were talking about testable code. So I sort of like have this document, which is, I think, a nice document. Um, and, um, I'll show this to you. So this basically goes through, um, well, some of the things we discussed and some of it we haven't discussed. So one of the ideas is so these are guidelines for writing testable code. Right. So guideline number one is that, for example, over here, there's a constructor which is, I'm sorry, there's a method one which calls three other methods, right? So so in this example over here, it's we don't have seams. The idea is that you want to break up your code so you could test parts of it, right? So like someone was giving me a presentation earlier um, about why you shouldn't put code inside a constructor. Well, that's because you can't really test the methods, the code because there's no return value, right? There's no way to access, if it's inside a constructor, how are you going to test for true and false, right? So it's very hard to write a unit test. So, so the idea is you don't want to write too much code together, and then you can't really test. each part of the code individually, right? You want to be able to see if it breaks to see what's breaking, right? If you're doing five things, you don't know, and you write a unit test and it returns false, you still don't know what happened, right? So you want to break up the code into what's called seams, right? Just like when you have clothing and if I pull really hard, where's it going to break? At the seams, right? Because that's what connects it. So you want to have a code to be like broken apart into little different parts so you could put your unit tests on those each little part. Okay. So, um, okay. So basically that's what I wrote over here. So this is bad code, right? So this would be, um, hard to unit test because it is doing so many things um, that a return of false still doesn't tell me what failed. Uh, and it is also hard to test each part, right? You can't really, if you're doing a lot of things together, it's hard to really test each part of the code, right? But when you break it up, then you could really attack it, right? You could say, does this part work? And then you could write 3 unit tests for that part. And then you could take part number two, part number three, and you could attack each one separately, right? So it's because if you have a method where it has a bunch of if statements, how are you going to test every part of it, right? Because it's just, it's very difficult to think of weird situations where this test might happen, right? Where this part might get called. So that's what seams are. Okay. Uh, then number two is what we did. I think somebody just came. Uh, no, I just accidentally hit it. I'm recording, right? Uh, yeah. Uh, okay, let me try this. And um, So then what we did over here was dependency injection, where we passed in, it's rather than having light bulb inside of this method, right? We passed it in, or they having the device or the time in, or let's say over here, instead of passing in the device, we actually passed it in, right? Originally, we had the light bulb inside of it, right? But then we moved it as a parameter, right? Right. So that's called dependency injection, meaning that if this test is dependent on something, let's pass. And it's not what we're really testing or what the method really does. So then it's better to pass it in, right? Than leave it inside of the method because then we could change what type of device is going to get tested, right? That was the example, right? So. Um, so meaning, I'll just write, i.e., we, um, in our example, we, um, um, uh, uh, we, we passed in, um, a mock light or, for testing and a real light for actual, use. Okay. Right. So, right, this was a method and this was another method, right? So, um, so we passed in depending on what we're doing, right? If we were doing real, we wanted the real light to go on, we passed in the real light bulb. And when we were just doing a unit test, just to see if it turned on or off, then we passed in the smock light. So we didn't need to, like I saw it work, like I asked AI to generate some code for me to test some code that was reading a database and it actually generated like a mock database connection, but I didn't understand how that would work. In other words, in other words, if you would run it like on a server, it wouldn't really require a database to be present, right? But I didn't know how that would work really because I didn't understand that because I was actually testing the results of the test. So I didn't really see how that would help me. So, because I wanted to see whether, if I run this, if I get certain results. So, from the database. So it's actually, so that wasn't, I mean, it was a good idea from AI to do it, but I actually needed the database to read it. So, because that was my code was reading the database. I don't know, maybe if I thought about it a little bit more, but whatever, that wasn't a good example. I mean, it wasn't, I don't think that wouldn't have helped me, because that's what my method was doing. Okay. Then there's something which I'm not sure how to pronounce, but I know what it means. It's called law of Demeter. I'm not sure how to pronounce it, but the idea is like this. Let's say, for example, I have a method, and let's say it takes let's say, for example, um, um, let's say in my light bulb, let's say I have a pattern. I don't know, just making up something, right? And within the light bulb, and then within patent, I have a um, uh, get patent or no, what's something that a real thing would have? Not a patent, let's say a um, a part ID, right? Cool. Okay, so I get ID, right? So let's say the part has an ID and sorry, get ID, and this would be a public and returns a string. Okay, and then let's say okay, let's say returned um, light. Um, I guess this is a bad example because it's specific to light bulb, but 1, 2, 3, 4, 5, right? So, okay, and then I put this inside my light bulb. So within my light bulb, I have um, a part ID. Okay, so what happened? Oh, I forgot to do the type. Okay, so then let's say in main, let's have a method called, let's say when I turn on the light, right, over here, I also, I'm going to print out, I'm going to also turning on light, and I'm going to also print out plus um, light dot, oh, what's the name of oh, I'm sorry. Um, would it? Oh, it's in here. Uh, oh yeah, I'm sorry. Plus part ID times get ID. So over here, I'm besides turning the light, I'm telling you the part ID of the light. Okay. And over here, also when I turn off, I'm doing that. Okay. Um, okay, so what's wrong with this? So what's wrong is that I'm over here looking at, or let's say a main, I'm turning on the light, right? And, or I'm trying to turn the light on or off, right? But, um, or let's say even in here in the timer, I'm turning on the light on or off, and but what it's actually doing is it's also accessing um, the I'm sorry, this is what I should do. Oh, okay, I'm sorry, I did it wrong. So uh, I was trying to make it simple. It got too complicated. Um, I wouldn't do it here. It would be here. So let's say over here within um, the problem is it doesn't know about that. Let's say over here. Okay, so let's say I do light equals to new light. So um, actually I'll do one more thing here. I have a method called I'm trying to think of a good example. Um, Let me just think for a second. So the problem is when I turn on the light, I don't want to um, okay, let's say um, you know what? Here, let me just do it, show you an example of it. Like, um, okay, I'll just make up an example over here. So let's say, for example, I have an object called, we'll do it like this. I'll just do real, okay. Let's say I have an object called, called A, okay? And A, I have another object called B, and then I have another object called C, okay? And within C is a um, is a method called, I don't know, do something. Okay. So void public void do something. And then um, doing something. Okay. And then uh, okay. And then within B, I have public C. So I have C is inside B. Okay. It's actually in real life, it's actually more common than it's hard to think of an example, but I see it all the time. Uh, and then within A, we have public. So C is in B and B is in A. Okay. So public B, B is equal to new B. Okay. So then let's say, for example, I have a method called, I don't know. Um, then in A, let's say I have I call a method called, um, oh, okay. No, that's good. So then I have a method over here called, um, I got to declare A, right? A equals to new A. And then I have a method called do something with A, right? do something with A. Okay. And I pass in A. Okay. And so let's declare it. So uh, I'll just declare it over here. A void. And it takes A as a parameter and it does something. Okay. And let's say pass in that small a over here. Okay. Now, okay, so what the law of the matter says is, uh, what's wrong? Oh, I have to make it static, I think, because the main is static. Okay. Okay. So over here, I'm doing something with A, right? So what does the law of the matter says? It says that when I say do something with A, I should not do this. I shouldn't do A equals B, that equals C, and C equals do something. Okay? That, I mean, it's going to work, right? But it's not good programming practice. Why? Because, oh, it comes out to main lines. Because let's say we run main, actually, we'll do something, right? But, uh, oh, doesn't like the name. Uh, Whatever. Okay. So if we go back to main again, so it's going to run, right? So it did something in C, I should say, right? Did something in C, right? So it's going to do something in C, right? So again, if we go here, but what's wrong about it is that it looks like I'm doing something in A, when really, what am I doing? I'm just using A as like a way to get into C, right? So I shouldn't call A is just calling using object B, which is then calling object C, which is then doing something. So if I look at the method, I say, oh, I'm going to do something with A. But really what I'm doing is I'm doing something with C, right? So this is like it's not obvious that what's going on here, right? I'm using A to access C. So really what I should really do is I should really pass in C, right? This would be the more accurate way of doing it because then it's obvious what I'm doing, right? Because, right? Because really I'm just using A to get to C, right? So the better way to do it would be I go over here and I'm obvious what I'm doing. So I go A dot B dot C, right? That then we look at this method, it's understandable what's going on, right? So the idea basically, the law of the matter is actually very simple to, it took me a while to show it to you, but it's actually very simple. You should only have one dot inside your method from the parameter, right? You should only use go down one level, right? So if I pass in C, I should just use the methods that are inside of C. I shouldn't use C to get to D, E, F, and G, right? Because if I want to do something with N, then it should be explicit in the parameter. Okay? So that you find a lot. In other words, you find people that call a method that says do something with A, and then it's really doing is it's doing something with a totally different object, right? When you look at that, you say, "Whoa, I didn't know it does that." You know, I didn't know that when I do something with A, it's doing something with the light bulb. It's kind of weird, right? So. Um, yeah, for example, let's say this has a light bulb, right? And yeah, that'd be even better, right? So imagine we have a light bulb in here, and this would be this would like turn it on or something, right? Turn it on. So the point is that if it would if we were passing in A and it's doing A dot B dot C, it wouldn't be obvious what's going on, right? I'd say, oh, um, I was just calling, um, A, and all of a sudden the light bulb's going on. What's going on, right? So, what happened? Oh, A dot B dot C. Right. So, so I'm running this, and all of a sudden I'm calling A, and all of a sudden, which doesn't have anything to do with the light bulb, and all of a sudden the light bulb's getting turned on. Right? So it's very confusing, right? So we don't want code like that, right? To, you know, turn on the light. We want to only do things that are inside of A. Okay? So that's the basic rule of law of Demeter, or Demeter. Um, okay. Now another thing is, remember we said that that well, we sort of touched on it, um, but there's a good example. Actually, you know what? We'll continue this next week, okay? We'll finish up on Tuesday next week because I just wanted, is a whole nother example I want to go through, okay? So I'll see you next week, and I'll post this, and you could watch this on YouTube if you want. It's very short, but I'll go over it in class next week, okay? It's going to take a while, a little bit to explain it. So, but it's a very good, it's a good explanation of what a side effect is, right? So basically, the idea is that you don't want your code to rely on things that if it has too many relies on too many things that are not integral to to the method itself, then it becomes very hard to test, right? That's called side effects. So basically, you just want the code to do one thing, and then you pass in the other things. So we'll cover this on Tuesday next week, okay? But I'll post it if you want to watch it. Um, and these are like examples, like if, for example, if you have a method that accesses a system, on the server, there might be no file system, right? That could be accessed, right? Right? Just because you could read and write on your computer doesn't mean that you could read and write on the server, right? Right? It might be you don't have permission to read and write. And the same idea of that if your method is referencing global variables, again, the global variables are like outside of your scope of your method, so someone else might be also accessing it. So you might not get consistent results, right? Um, Okay, so we'll go through this. Oh, actually, this was the one we did was the current time, right? And also, if you're relying on if you're going to have random numbers, so then also your results are not going to be consistent, right? Or predictable, right? And a unit test has to have a predictable result, right? Okay, so we'll finish this up. Um, um, and we'll finish this up next on Tuesday. It's a little bit too much. And this is my favorite word, by the way, idempotency. You say that in a job interview, you get the job. Because the person interviews you has no idea what it means. I never knew what it meant till like a year ago. Someone mentioned in a meeting, and no one knew what he was talking about. And basically, idempotent means it's a math term. It means that every time you do something, you get the same result, right? Do you ever heard that word before? But it's really good for a job interview. Write it down, right? That your code has to be idempotent. For unit testing, you have to be. Just throw it in somehow. Say by the way,
So,
what?
like doing the same thing over and over and expecting the something different means you're an idiot.
I'm sorry.
No, like I think, but like if you keep doing the same thing over and over again and you get the same result, you're an idiot.
Oh, right. Right. But with unit tests, we like that, right? We like doing the same thing over and over again and get the same result. Right. Right. But I think it has to do with math. That but it's used in computer, and right, like that you want the same result each time. So you don't want, because otherwise your unit test's not going to work, if you call twice, right? It only worked if, let's say it's writing to a database, let's say it's creating a person. The next time you run it, it's going to, it's a big problem, right? Right? How do you write a unit test for a database? Because let's say your code, one of the unit tests is to add a new person, user, right? Well, you run the test once, then you run it a second time, it fails because the person's already in the system, right? So it's a big problem, right? How would you solve that problem?
Make the system, prevent external factors from changing it.
No, I'm saying, but how would you actually write a unit test that adds a new user to the database? Like that would, so that could run, as many times as you call it. What?
Like, it's-
No, you want to, but unit test oh, you mean random users, you mean? Oh, I see. That's not a bad idea. And you just see, you make up random names and hope it's not in the database already, right? Well, okay, okay, that's an idea. There's another way to do it is, I can think of two other ways. One that we actually use at work is we keep a snapshot of the database, and before the test runs, we restore it to the previous. You could do in certain databases, you restore it, right? But I just saw a different way that I think that of doing it, which is you would just check for that name, delete it, and then you'd run your unit test. So before the initialization code would check for that name, delete it, and then the unit test would run afterwards and would add it. So it's not so great, but but it doesn't, but it doesn't, but I like your idea also, random names, and then generate some random name, and then it probably won't be in the database, see if it gets added correctly, you know. Yeah, that's another way to do it. But then your database after a while gets filled with junk. So, so like I said, at work, we do like, we just take a snapshot, but that's also a pain because every time you change something in the database, then your snapshot won't work anymore, right? Let's say you added columns to a table, so then you have to take a new snapshot, but the new snapshot might has different data than your old snapshot. So you might, so it gets very confusing, right? You want to somehow update the snapshot without with keeping the same data. It's not so easy, right? It's more of a problem. It's actually an interesting problem. So, yeah. So I think maybe deleting the user before you run would be a way to do it. Yeah. Or your way, adding random users, or maybe or the other way it could do is you add the user, make sure the user is there, and then you delete it, as a cleanup for your test, right? You add a user, right? Make sure it exists and then delete it. Yeah, that would also work, I guess. So either way, unless someone already added that user to the database. And yeah, okay, whatever. So there's pros and cons of everything. So, but snapshot is very hard. I mean, it's only when you really have a lot of complex data you want to take, because it gets very hard to manage. Okay, so I'm sorry. So I'll upload this file. You can look at it and we'll finish it. And then we're also going to do chapter 9 if you want to look at it. But it really is a lot of words. And I just like sort of like cut out a lot of that. Chapter 9, just stuff I thought was important. So if you really want to read it. But I'm just going to go over the main points of chapter 9. So, okay. So see you next week. Okay. So have a good weekend.